So as we were looking at our goals, number one, we are going to be graphing relations, which we did yesterday. Today we're going to identify functions and also evaluate functions. But one thing I do want to point out is the vertical line test. And how do we describe the vertical line test? Well, it says that on the graph of a relation, if any vertical line intersects the graph more than once, then it is not a function. I'll clean that up, thanks. Then it is not a function. So today we're going to spend some time on domain and range and also on evaluating functions. Just want to clarify here on page 2, part C. Let's go ahead and make sure that we get our domain and range written down. If you would like to abbreviate domain and range using simply a D, that is fine. And it doesn't have to be capital. And remember, when we write the domain, give the list of, we always start low, and we write all the numbers, but we don't ever repeat. So in this case, 6 repeats, and I don't have to write that again. And over here, my range are the types of numbers that come out. And in this case, the types of numbers are specific. There are specifically 4 numbers that come out. A -7, a -5, a -2, and finally a 3 comes out. Now let's refresh ourselves about what relation versus function means. A function is consistent. A function is consistent, meaning if you ask it a question, you will get the same answer every time. So please explain to your neighbor, why is this not a function? What's the key part? If I were to map out the 6, notice the 6 says the first time we get it, we get a 3. The next time, we get a -2. That's inconsistent. It's like saying, do you like me? Yes. Do you like me? No. Okay, I'm not going to marry you. Forget about it. Forget about it. So this one is not a function. All right, so let's take a gander here and see what our domain and range. So I'm on page 3 now. And what we want to look at is, number 1, it says asks to find the domain. Then it asks us to find the range of each. Then we're going to do the vertical line test to see if it's a function. So first off, domain. Before, we gave a list of numbers because that was within the table. Then with the circle, we said, oh, there's a max and a min. Well, what about this one? What is the highest? So look only on the x value here. What's the highest it gets to? It only gets to here and everything under. So that means x is going to be less than or equal to 3. So notice in this case, the upper limit is just 3, and the lower limit is -infinity. So we don't even have to say -infinity, it's implied here. Now what about my range? If I look on the y, when does it stop going down, and when does it stop going up? And the answer is it doesn't. So because of that, my range is all real numbers, and I'm going to use this fancy R to abbreviate real numbers. Is this puppy a function, yes or no? So we just check a vertical line here, a vertical line. Does it intersect more than once? Yes. So here it intersects 0 times, so let me change the color real quick. This one intersects never, so it never hits the black. This one intersects exactly once right there, but this one intersects twice here and here, so I would say not a function, because all we need is one example where it intersects more than once, and this is the one example. Clearly, you could come up with an infinite number of examples, but this is the only example we need. So the domain on this one here, since it goes forever in this direction, our domain is going to be all real numbers. And what about the range? Range. Now notice here, does it stop going down? No, it looks like it goes down. It just goes down slowly. So in this case, it turns out it's probably all real numbers. Now, some of you, if you were forward thinkers, you might say, wait. It looks like what happens is that it starts to flatten out here. You don't have to write this. I'm just giving you an alternative explanation. And it turns out it is mathematically possible for something to approach. So notice my graph is approaching this green line, but never, ever, 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 ever touch it. That has a very special word, and we're going to look at it in much more detail later. It's called an asymptote, and it means it gets close but never touches it, okay? Like that all-elusive person you're in love with. Good. Now, if we start thinking about it over here, it acts like a function. Over here, it acts like a function. Over here, function. But the moment we get somewhere in this range, notice we get a triple homicide. So in that case, it is not a function. Again, if you are French, no function. I'm just kidding. Not a function. It's not a function. All right. The last scale that we're going to look at in this section, and yes, tonight you have assignment. We are going to evaluate, and let's recollect in our olden days what the word evaluate means. It simply means to substitute and simplify in order to get a value. In other words, how much is the function worth when you plug a 3 into this? Like, for example, how much do I pay if I buy 3 pairs of jeans? 2 pieces of notation we want to mention out to you. This entire beast here is called function notation. We'll unpack that in future time. But for now, what makes it function notation is that it has a name of the function, notion. There we go. And what makes it function notation is that it always comes in this form. Some letter with parentheses and your variable inside there. Okay? Now, some things to consider. Number 1, this is exactly the same meaning as y equals. Y equals 2x plus 3. Y equals 4x plus 1. Okay? These are synonymous in how they're used. You can call this function y, or you can call it some function named f, that when you substitute an x, you get something in. Now, the next part is this is how we read it. We say f of x. That's how we read it. And if I put a 3 in, I would say f of 3. So let's just walk through the first one here. F of 3 is equal to 4 times 3 plus 1. Now I'm going to continue to simplify f of 3. Notice you need the parentheses every time. It's good grammar. Here I'm going to simplify, but you could have simplified it all in one step if you so desired. So the answer, when I evaluate this function at 3, I get f of 3 equals 13. The benefit, yes, so that would be left. My result. Okay, so let me explain again what this is. This here does not mean some letter f times 3. It's not what it means. It says I have a function whose name is f, and when I plug in a 3, this is what I get. So this f can be any letter. It can be g of h of h, or g of x, h of x, anything. It can be capital letters, small letters, etc. So f is just the name of the function. The parentheses just tell you what I'm putting in at that given moment. So notice that down here gives me quite a bit of information. I have a function named f. When I plug in the 3, I get a 13. So this is called function notation. Function notation. So let's look at the next one. If I were to rewrite this one, I would say f of 5 is equal to 2 times 5 minus 11. And now we simplify that. to finally get a result that f of 5 is going to give me some number. And I'll let you finish that one up.